Thanks for attending this meeting. We are going to tell you something about, let's see, it's going to, yes. We're going to tell you something about high performance computing at Aegon. My name is Mark van Goor. This is my colleague Nabbi. We are both working in the finance department at Aegon Netherlands. And we've been working with the Azure stack environment since 1 or 2 years. First we started just experimenting on seeing what we could do in the environment, what's all there, what's new, and what new technology we could use in the whole area. And in due time became more and more in the calculation of high performance computing away from what we already did. We were already experiencing issues in the normal HPC running calculations that we did, and then we moved over to the Azure Batch functionality to do the same and to do much more in parallel, do it quicker and those sort of things. And that's something we want to take you through. The agenda for the session, first maybe for the people who don't know Aegon, a few words on what Aegon is, what we do, where we are. Then we have some notes about big data. So everyone thinks big data is only in marketing and those sort of areas, but at least also for us in finance department, there's a lot going around. So I want to give some background about what's happening there. And then we move over to actually modeling in R. So what are we doing there? Why did we go to the R environment? And then we want to take you to the solution that we have set in place now, and also talk you through some of the items that we have seen in the past where we ran against, and which items we had to change to ultimately come where we are. And then we end up with conclusions, some benefits, some steps we are still working on and we're going to improve and change. And hopefully you can learn from it and take it into your own business and see how you can do the same, or maybe advise us on how we should not have done it. First part is very briefly Aegon at a glance. Aegon is a life insurer, also doing pensions, mortgages, asset management throughout the whole world. We have about 30 million customers. The roots are, it started mid-1950 here in the Netherlands, and now the main part of Aegon is in the US. Approximately 30,000 employees in the Netherlands. It's about 2,000 for Aegon Netherlands. State and financial sector is that most of the earnings are coming from the Americas. And only 1/3 still in the European Union, for which then the Netherlands is it's the largest part, and the second largest is in the UK. But we're all over other countries as well. Then some notes about big data in finance. So what are we seeing? In the finance department, we have a lot of financial calculations. So every month we have reportings. We need to report to the Dutch central bank, to the investors, and all the stakeholders. And therefore, we, at least on a monthly basis, we need to do calculations on the whole portfolio. So that means for the pensions, for the life portfolio, for the mortgages, for the assets. And what we do each month is that there are a lot of cash flow calculations. So we do projections in the future. From the cash flows, we calculate discounted cash flows again back to get the market values. And we don't do that one time, but we do projections up about 30 to 50, 60 years, depending on the length of the products. But we also do a lot of scenario calculations. So there's a lot of parameters that we do. If we say, okay, if the interest is going to increase by 1%, if the interest is going to increase by 2%, what happens if death rates do increase? What happens if the inflation increases, decreases? So there's a lot of variations that we actually run through the time. And in monthly basis, we only do a limited set of data. But in the quarterly runs, it's a huge amount of calculations. Just an example, we're just finishing the quarterly work for now, and only for the life and pensions calculations, I've done about 2,000 cash flow calculations, doing all projections for 30, 50, 60 years with more than 1,000 different scenarios in those sort of areas. So, and then we have those scenarios calculated, but still we also have a lot of interaction between the portfolios. So we do a lot of analysis on risks, on the outcomes of projections, and those sort of areas. And that will ultimately, it will lead into the financial reporting for us. So there's a time pressure on the whole area that we're doing. For the actual calculation time, it's about 4, 5, 6 days that we have time to do all of those. And we actually want to squeeze them in a much less time, so that we can do more calculations and otherwise also be able to report quicker. Just an example on how that works on data explosions. So you see, in the first place, we have one loan that needs to be calculated, just as an example. Then we need to do a cash flow projection for it. And if you're talking about loans, then we only have loans that are at max for 30 years, so 360 months ahead. And we need to do that for each loan. And if we have calculated the cash flow for each loan, then again we do a discount factor, and we have then the actual cash flow for such a loan. But we don't do that for only one, but we do it for one, the first shock A, and then we do the same calculation for B. And then the variance comes is that we have a lot of loans. In the example, we have more than 400,000 mortgage loans that needs to be calculated. And what I just said, we have a lot of cash flows for each of them that we need to do on an individual basis. And even further, if you go to the discount values for each of those times for each loan, we have all those multiple scenarios. So you can understand that if we do this actually on a monthly basis, not only for the mortgages but also for the life, where we have more than 1 million products to be calculated, then you will understand that the size of the data that we're actually producing every month is very huge. What we saw in the past is that when we also only had limited values and only had limited scenarios to be calculated, it was roughly about 2 terabytes of data that we're creating. But then we were just limited in the time of how much we can produce in the reporting period. If you see in this example of the mortgage, I already said it's more than about 400,000 loans. We have about 10 parameters that we want to take through. We have 2 projection horizons, so we do it in 2 times. We calculate 1 time until the end time of the interest period, and we do a second calculation through the end time of the whole loan. In the mortgage area, that's indeed a maximum of 360 months. And up until now, we only calculate 15 different scenarios. So what I just said, if the interest is going to increase, if the costs are going to increase, or if the costs are going to decrease. Ultimately, we want to do much more, but given the time and the reporting schedule that we have at this moment, we are just limited to 51. But actually, the actuarians say they already on this portfolio, they would like to do maybe 30, 60, 100, 200 scenarios, just as much as possible. If you only see this part, then what we in the new way of working are doing, and that's what we will explain further. We actually also storing all these intermediate results, because what we did in the past is the existing application that we have for the calculation of the of this part. It's doing a cash flow calculation, it's then doing a discount, and if we do another scenario, it's again doing the cash flow calculation, doing discount, again cash flow calculation. So there's a lot of calculations that are repeated each time, and that was one of the areas where we wanted to save some time, do each calculation only 1 time. The disadvantage of that is that that means that we need to store all the individual data. And you can already see in this example where we now are in the new environment, that we actually store it each time. And that means already that only for this calculation, what we do in a month, it means that we are storing 5 terabytes of data for these calculations only. This is a bit of the background on the concept that we then started working on, because we said, okay, we're now doing this in 4 days, and we actually want to do it in 4 hours. So how are we going to achieve that? And that's the more what Ali is now going to explain you about.
Thank you, Mark. I'm Ali. I joined Aegon about a year ago. I'm focused on high performance computation mostly in this project. Our first question might be is that why R? So as soon as we start searching a little on the Google about the data science, the first battle comes with R versus Python. So we have some obvious reasons basically. So powerful in memory computation, flat learning curve for our non-IT users, and of course statistical packages and quantitative packages will be a great help. But our initial thought was because of R on SQL Server 2016. However, after multiple tryouts, we realized that we cannot gain performance without parallel computing. In that direction, actually, Azure Blob Storage, Azure Batch, and Azure SQL Data Warehouse helped us achieve this goal, and also relax the environment from the choice of the data analysis tool. So with this environment, we can actually run our data analysis with both of these choices. I'm going to walk you through the solution, but what is our major aspects? One is clear separation between the environments, so mainly test, acceptance, and production environment, so which ensures that the data, for instance, in the production environment is completely encapsulated from any changes during the testing and development, for instance. Second, high performance capability and scalability give us power scale at low cost that we can actually run it for all the underlying financial models regardless of their complexity. For those who work in the financial sector, they know the significant importance of the auditability. So the transparency here is really important, and the fact that we need to monitor every detail in each level of the process. So let's talk about the architecture a little. So Azure Blob Storage together with Azure Batch will construct our virtual machines which run specific tasks and actually communicate with data warehouse, get the data from the data warehouse, write it back to the data warehouse. And I'd like to go pretty quick to the underlying. One of these virtual machines can run either R or Python or whatever language they're interested in. We set some principle to just have a logical blocks. So one script is going to execute over there a block for data loading from the data warehouse, start the computation, and write it back to the data warehouse again. And in every point, we want to log the results into the logging, so to ensure that we have this inspectability at full power. Let's talk about the evolution actually here, because our initial solution was a simple C# console application. We started with blob storage, creating multiple containers, namely application, job, and output container. I shortly describe what is the purpose of these three. We use a Microsoft AZ copy to move all the data between the VMs, blobs, and entire solution. So what application container does is actually installing AZ copy within those VMs and make sure that all the files we uploaded to the containers will be there in the machines. And we have a job container as well. So job container is actually contain all the scripts, all the financial model they want to run within those machines. So if it's a simple cash flow projection, for instance, uh, I think we need extra files for instance, install R over there and install the packages. So all of them goes to the job container and distributed over the VMs. It starts computing with the previous method that I showed in the previous slide. And of course, we have 7-zip, R installer, R packages, and R scripts. The question is why we need this actually 7-zip, because we actually, AZ copy couldn't copy the folder directly from the container to the VM, so we actually have to zip that one and unzip the folder in the VMs. And then the whole environment is set for the computation. And after the computation is done, we write it back to the output container. And of course, with the fastest, the most efficient way to load it to the data warehouse, talking about experience, is the polybase. We write it, the whole output to the data warehouse. As a temporary solution, we write that logging directly from the VM to the data warehouse. This is, I'm sure you have a solid argument that it's not a good idea because the data warehouse is not designed for such a purpose, but that was the temporary solution at this point of time. Let's go forward. So we learned a lot actually in this initial solution. Mostly because of the concurrency and overloaded connections. So this pool over there can be thousands of machines. And the connection between the job container can be easily overloaded. So in very first point, to just populate the machines, we fail to actually run some of the machines because of this overloaded connection. So one is actually this red dotted there, and same concept goes with the output. So we miss some output back from the machines, although it might be completely computed and over there, but during this copying process to the output container, we miss some. And for some obvious reason, logging failed as well, because we have like 4,000 machines at the same time want to write on the data warehouse, and the control node cannot handle that number of connections. I found actually these issues between these two different products, so data warehouse and versus database. So I like to have a really quick comparison actually between these two. So database, we can have lots of concurrent queries, lots of active connections with that, but the size is limited. On the other hand, we have the data warehouse, so we have a unlimited size, but we have a limited connections. So this our solution actually fills this gap a little. So we can have this unlimited size. We cover the connection problems. So how we did that? It's with the same setting at the very first point, creating the containers in one storage, and then we actually use distribution basically. So we duplicate exact same setting into multiple accounts, and each account has job and output container. Again, for constructing the pool, we don't need actually to have the application container because we just construct the pool once. So this one actually construct the pool, and then with the random connection to the job container from the child accounts, then we can actually lower the load of the connections to the VMs. So the problem will be solved actually on the input side, but conceptually it should solve on the output side. However, I found it some hard concept that why when we have these multiple accounts, why it's not working on the output side. But yeah, I would blame law of large numbers. So as soon as this little chance of error happening over there, we miss some task. And in financial sector, it's impossible actually to convince the client to give up one assets. So we have to monitor the file delivery basically here. So we designed this task retry mechanism. So what this task retry mechanism does is just monitoring closely what's going on in the VM and what arrived into the application content. Sorry about that. Output container. It just monitors if the task is completed, so the files are on the VM, and if it arrives in the output container. If it's not, it keeps waiting in a couple cycles. And if we keep failing on that, it will send the task back to the pool for recalculation and repeat this one finite times. And after a couple cycles, if it's keep happening, we will blame the underlying model over there. So the solution in action. Again, in our mortgages portfolio, we designed this modular case. Each white block is actually using the same architecture. So in very first point, it's just one machine constructing, extracting all the data, clean the data, make it ready for the computation, send it back to the blob storage, and the second module, I name it computation engine, which can have the parallelization, starts and produce the data. And at the latest state, we might have, in mortgages case, we have to have the report generator. In general speaking, we can have another stage of reduce. So since the first and third module is quite a small machine, we can actually write the logging directly to the data warehouse. But later on, we come up with a better solution to have the technical logging while computing this big pool during the computation engine. I'd like to talk a little about the deployment. You're familiar probably with this graph. We have multiple builds. One is the C# solution. So we construct the parent storage account with all the files that we have in the VSTS repository. We compile the solution and build an artifact. So, simultaneously, we use just an XML file to carry the secrets to Key Vault, which gives us all the credentials to the specific environment. So using these two, we can actually just run the whole model with a specific environment. So in the very first point test, and with the different XML, different build, different key vault to the different environments, we can move it to the acceptance, and so does. So same for the production environment. As conclusion and the future direction, in terms of performance, at this point, we actually I construct this parallelization within C#, but I like to actually have it in R to just give the developers the full flexibility to go with the, their idea about the best optimized way of parallelizing the solution. Also, the task retry mechanism, I believe we can actually improve it with a way optimized algorithm. We already talked about the data size, storages. Auto deployment of the child accounts is important because at this point we have a static number of storages. When the size of the pool gets bigger and bigger, in some case we need more than static 10 or 20 child storage accounts, and I like to actually have this auto deployment to have the complete flexibility over there. And at this point, task retry mechanism just monitors one output from the VM, delivers to one of the storages. So this is actually a big restriction for the data modelers. The next improvement is to monitor multiple output from each task. And we have some communication with product group about the storages. They recommend us that file stream allocation is much better if the file names has anti-pattern title, basically. This is the part we have to include as well. We already talked about concurrency and active connections. And also, by replacing the direct logging from the VM to the data warehouse with message bus, we can just write all the logging during our computation to the data in order to have an inspectable environment. What I like to have is auto scale of data warehouse. So this is the one of the great powers of data warehouse, that we can actually scale it whenever we want. So during this whole process, there is a certain point that you might need a larger scale on the data warehouse. So I actually wrote a small method to automatically scale it up. But the fact that when you change the scale, the data warehouse will be paused for about 12 to 15 minutes. And turns out I'm not the only one working with the data warehouse, so my inbox was full of emails that what's going on. All of the models are failed, but conceptually the query will be paused, but all the models that execute those query will fail. So auto scaling is a good idea for specific model, but we have to actually think it in a really big picture when it comes to the teamwork with the different models, and when to scale it up, when to initiate this one. And of course, since it's about a year, I'm working with this one. Still, solution is a little static and quite hard-coded, and our team are working on the dynamic solution to make it less hard-coded, really flexible for all the possible modeling. And yes, for the key vault, it's important because delivering the credentials, there's no doubt it's not a good idea on the security-wise. And key vault is the one going to hidden all the credentials, but also give the full access to the developers, to the testers, to use the same solution. Well, that's all. Thank you very much. Oh, 17 minutes. Azure Data Warehouse. Azure Data Warehouse we're using. Yeah. At this point, we are 8 developers. Yeah.
And when we started this concept, initially we started together with Microsoft, because we said, okay, we want to do parallelization. How can we do it better than we already have? Then we started indeed with SQL 2016 on R, because that was announced, I think, 2 years ago as a new way of working. And we started doing that, but then already quickly we saw that parallelization was not going well. It was only on that machine and not much more. And we actually wanted to do a lot of calculation in parallel. So then we started talking with Microsoft, and they suggested that we could also do something with Hadoop clusters and those sort of areas, but also could stick to HPC computing using Azure Batch, which would be a similar concept. And then together with one of the colleagues from Microsoft, we started looking on, okay, how can we do it in a simple way? So that was the first concept of the application container, job container, output container, but it was very small, very limited one, and we saw that worked. But then we came into the large numbers, where we actually were the largest one we've done, I think, was with 10,000 cores. And then we run into the issues that the output was not coming back, that some of the tasks were not starting, some of the cores were not going. And then together with them, we're looking again in how can we solve this one? Can we use Azure Data Warehouse? Can we go to premium databases? Can we use Azure Storage Account Premium? Those sort of areas. And ultimately, we come to the solution how we have it now. So just the Azure Data Warehouse using master and the mother and child accounts. And as you just said, we are currently still looking in that concept, because Microsoft already stated that it should not be necessary to use those multiple accounts. And there we already have done some additional test runs to see how we can improve that one. And one of those, what you just explained, is that we should much more use variable file names, because that should work better on the concept of the Azure Storage Account, whereas than actually spreading it much more out over the whole cluster. So there's still some work on it to do, and still see if we can do improvements on that. And I think that's a very nice way of working and coming together into the best approach and the best way forward for this solution. We did not check other ones, so we already did see a lot of benefits on the Azure environment, also in the BI area, on the way of working and the products that were available over there. So actually, we're coming from a private cloud, and at this point of time, but looking at the size on what we wanted to do and the availability of products and the quick development of what's going on everywhere. We came up to this environment, and then we just started work on that, and now we are where we are.
I found it really easy to tie all these products together to build an environment without interacting with a specific underlying model. So with all the model developers, financial developers, they can just focus on their modeling without considering the environment on top. So we always monitor what they need. We consider it as a really big scale for them in case they want to deploy it in this environment. And it's actually not really dependent on the model that we are running in this environment. So they don't need high-tech C# knowledge or cloud knowledge to do that, but yeah, they just focus on our on the financial modeling, and then they can actually use this one. And the fact that we can actually switch between this, tie all these products together, for instance, that premium database, that was an interesting experience. Right. So again, between this big difference between the data warehouse and the database, but yeah, it keep evolving, and yeah, it's going in the good direction, I would say. Further question?